Hello everyone, I am Deepak Paliwal. In the previous lecture, we have learned about the results shear stress. So, in this lecture, we will talk about the Schmidt's law. So, in this lecture, we will talk about Schmidt's law. Schmidt's law. Actually, in the last class, what the equation we have deduced is again I am writing tau is equal to sigma cos theta cosine lambda. So this is the Schmidt factor, and when sigma becomes the sigma y, this tau becomes critical resolved shear stress. This is Schmidt factor. Okay, so now the question here, when this Schmidt factor is depends on the loading direction and the angles between the loading direction and the slip plane, or the loading direction and the angle between the loading direction and the slip direction. Okay, that means the theta and lambda. So when we change the theta value and lambda value, what would change, like sigma y or tau crss? Because the sigma y is the material property, tau crss is also a material property. So there is a lot of experimentation was done, or experimentation was performed by the Schmidt, and they have deduced the equation, or they have deduced, or they have concluded from their experimental work that the critical resolved shear stress value for a particular plane for a particular loading direction is the constant quantity, and the only variable is sigma y. That means tau crss divided by Schmidt factor is equal to sigma y. When our Schmidt factor is increasing or decreasing, that means the change in the Schmidt factor will give the changes in the sigma y, and this tau crss is constant quantity. So consider a case 1, when we want easy plastic deformation. Easy plastic deformation means our sigma y value should be very low. Then only the plastic deformation can be easy. So from the equation tau crss, we know this quantity is constant and only the variable is Schmidt factor. So to uh, increase the value of Schmidt factor can only give the lower value of sigma y. So here we can say, let me have a slightly different color. When we increase the Schmidt factor for a particular plane, the Schmidt factor value is very high, then only the sigma y value is very low. That means the resolved stress on that particular plane, suppose this is our material, so the resolved stress by applying the sigma load on that material, the resolved stress on this particular plane is very high, which is exceeding the tau crss, exceeding the tau crss value. So the plastic deformation becomes easy. Again, consider the case 2, when we want our material to deform with difficulty, or you can say the plastic deformation is not easy. In that case, the deformation is difficult. That means sigma y is very high. So tau crss by sigma this Schmidt factor. So Schmidt factor is if low, that means the sigma y will be very high. That means the position, or the orientation of this particular slip plane is such that the tau, to achieve the tau value greater than the tau crss, we have to apply large amount of sigma value, or large amount of the sigma value, so that the material achieves the sigma y value very high. Then only this tau value becomes more than the tau crss. In simple words, we are applying the sigma value on the material, and this sigma value have some component in form of the tau on an arbitrary slip plane. When the Schmid factor is very high, that means the Schmid factor, here we can say the Schmid factor is high, that means the orientation of this particular slip plane is such that the little amount of this sigma value increases the value of tau such that it is greater than the tau CRSS. In the other case, when we are applying the sigma which is giving a tau component on the slip plane, the Schmid factor, the orientation of that slip plane is such that the Schmid factor is very low. So if the Schmid factor is very low, then we have to apply the large value of the sigma to get the tau which is greater than tau CRSS. So this is what Schmid has given in the previous time with the help of his experimentation, and showed that the tau CRSS for a particular slip plane is constant quantity. The variable is sigma y, or the yield stress. So this is the Schmid law, or the discussion about the Schmid's law. We will meet in the next lecture. Till then, thank you. Bye bye.